Our universe's hidden gems. What are exomoons? They are moons outside our solar system. They orbit exoplanets, which orbit other stars, not our sun. Think of Earth's moon, but very, very far away. This distance makes them super tricky to find. Exomoons are different from exoplanets, which are the big main bodies we often hear about. Moons orbit these planets, like cosmic companions on a grand adventure. They can tell us so much more about distant solar systems. They offer brand new places to explore with our telescopes. So why are exomoons such a big deal? They are super exciting for science, especially for astrobiology. If planets can have moons, then maybe, just maybe, some of those moons could host life. Finding exomoons is a new frontier in astronomy, like discovering whole new types of worlds. Exploring them helps us understand how planetary systems form and evolve over billions of years. Let's talk about the habitable zone, also known as the Goldilocks Zone. It's where conditions are just right for liquid water to exist on a surface, which is super important for life. So can moons be habitable? Yes, absolutely they can. A moon can be in its star's habitable zone if its planet orbits the star right there. This means it might have liquid water on its surface. But wait, there's more. Moons have another cool trick called tidal heating. Imagine a moon orbiting a giant planet like Jupiter or Saturn. The planet's powerful gravity squeezes and stretches the moon, creating friction and generating heat. This internal heat can keep water liquid, even underground, meaning a moon might not need to be in the star's habitable zone. Think about Jupiter's moon Europa or Saturn's moon Enceladus, which are icy on the outside but have vast liquid water oceans underneath. Scientists have been searching for exomoons for years. It's incredibly challenging work because moons are usually much smaller than their planets. But astronomers are clever and determined, developing new methods and tools. They found the first strong candidate for an exomoon in a habitable zone, orbiting a giant gas planet called Kepler 1625b. The exomoon candidate is named Kepler 1625bi and is thought to be large, maybe even Neptune-sized. They primarily use the transit method, where a planet passes in front of its star, blocking a tiny bit of the star's light. If that planet has a moon, the moon can also cause a small dip in light or change the timing of the planet's transit. The Hubble Space Telescope played a big role providing crucial data. They observed the Kepler 1625b system and saw a second, smaller dip in light after the main planet's transit. This hinted that a moon might be trailing behind the planet. More observations are needed to be absolutely sure it's a moon. But the evidence so far is very promising and super exciting. This discovery is a huge moment for space exploration. What makes a moon livable? Challenges and wonders. For a moon to host life, it needs certain conditions like liquid water and an atmosphere. An atmosphere acts like a blanket, protecting the surface from harmful space radiation and keeping temperatures stable. A magnetic field is another big plus, deflecting harmful solar wind and cosmic rays. Without a good magnetic field, a moon's atmosphere could be stripped away, making it hard for life to survive. Many exomoons will orbit large gas giant planets with strong radiation belts. This could be bad for any life on a nearby moon's surface, unless it has serious protection like a thick atmosphere or a strong magnetic field. This discovery of a potential habitable zone exomoon is huge, like when scientists found the first exoplanet. Exomoons are opening up a whole new chapter in our search for life beyond Earth. The possibilities are truly mind-boggling and wonderful. The search continues. Future of exomoon hunting. How do we keep finding these tiny distant moons? We need incredibly powerful tools and brilliant scientists. Telescopes like NASA's Kepler Space Telescope, TESS, and the James Webb Space Telescope, JWST, are game changers. JWST can study the atmospheres of exoplanets and maybe even large exomoons. Future missions like the European Space Agency's Plato will search for Earth-like planets in habitable zones and potentially spot exomoons. Ground-based telescopes are also getting major upgrades with new sensitive instruments. First, we need to confirm more candidates like Kepler 1625bi. Scientists hope to find many more exomoons and learn about their sizes, masses, and orbits. The search for exomoons is an absolutely thrilling adventure, like being cosmic detectives. Each new discovery tells us more about the vastness of the universe and our place within it. Join the adventure of discovery. Please like, share, and subscribe to this channel for more exciting content on exomoons and other cosmic discoveries. Stay tuned for more. But before we go, let's take a moment to appreciate the grandeur of this journey we're on. Each exomoon we discover is a step closer to answering some of humanity's most profound questions. Are we alone? What other forms of life might exist in the universe? Imagine the day when we finally detect signs of life on an exomoon. A moment that could redefine our understanding of life itself. It's not just about the science, it's about the stories we create, the dreams we chase, and the collective curiosity that drives us forward. So, dear exomoons, keep looking up, keep wondering, and keep dreaming. The universe is vast, and our journey has only just begun. Join us as we explore the final frontier, one exomoon at a time. Thank you for watching, and we can't wait to share more incredible discoveries with you.